You know, I've noticed they always use some British accent people to do these things. Like, I'm wondering how does it sound like if you're a Jamaican, you know, with talk like that. I say, yo, this a meeting I got start. Or, you know, hang up, meeting lock off, or something like
The
that.
meeting starts.
The meeting start. All right, you guys finished with the diagram?
1 second, sir.
Yes, sir.
All right. Are you finished now, mom? Or is it right?
Sir, I had to rub out something. Give me 1 minute, please. Can go ahead, sir.
All right. Hold on. Okay, so position vector. It says what? The position vector is a movement from the origin to the point. So the position vector of a point AXY is OAXY. So what it is talking about position vector is that they're really talking about the origin. All right, it's all about the origin. So if you look at this diagram here, let us say you want to go from A. Let me zoom in a little bit. All right, class. So let us say you want to go from point A to point B. So this is point A, and this is what? Point B. All right. So to go from point A to point B, you can go directly. All right. Or another route is to go from A to where? To O, that's the center. And then from the center, which is O, back to what? B. So essentially, A to B, the vector A to B, the vector equation is from what? A to O plus O to B. Whoops. Hold on to that now. It's all right. O to B. So that will be your vector equation. So please make a note of that. So this is our vector equation for a position vector. As a matter of fact, this is very standard. Because if I were to change these letters P to Q, suppose it was PQ. You want to go from P to Q. What would be the vector equation, class? P to what? P to where? P to?
P to O.
O, right. Because you always have to go to O, and then you start back at O, and you end up at where? Q.
Q.
All right. So this is a standard pattern to write a vector equation for a position vector. All right. All right. Any questions so far?
Could you go over that one more time, sir?
No problem. All right. So basically, let's run it again. A position vector is a vector that originates from the origin, you know, or its movement through the origin, basically. All right. So if I say I want to go from vector A to B, all right, I can go directly, or I can go from A to where? O, then O to B. So we have this vector equation, A to B is equal to A to O plus O to B. And what I was inferring is that if I change the letters, let us say this is not A, let us say this is P, and the B is Q, what would the vector equation be? So PQ would be from P to where? P to O.
P to O and
Right.
then
O
O to Q.
Right.
Okay.
Suppose it wasn't P and Q. Suppose it was XY. Can somebody tell me what the vector equation is? XY.
It would be X to O and O to Y.
And O to Y, yes. Very good.
So, sir, what if you start from you say you could start from A, go straight to B. You'd get
No,
the same answer?
but that's all right. Let me tell you. I was gonna mention something like this. One of the reasons why we can't go from A directly to B is because we don't know the values. So I'm saying we don't know what the value is. That's why we go from A to O to B. Because
Okay.
if we had known what the value is, then we could just work it out. All right. In this case, you see the graph, we could actually work out the value. Because all we need to do is just to what? Draw a right angle triangle. All right. But take off this for me, please. I don't want it to be too chunky. So this represents the vector equation.
You mean position vector equation, sir?
Yeah, same thing.
Okay.
All right, let me know when I can move on. I should be able to move on because you already have this diagram, aren't you? All right, let us get into it a little bit more. All right, now we have the point A, right? And we have been doing a lot of graph lately at Wilmot, right? Whole heap of graph, not true?
Yeah, tell you, sir,
Come
boy.
on, sir, kill with graph, not true? All right, don't worry, man. It soon be over. Well, unless you're gonna go university, or college. But we have the point A, and the point B. Now we can write a coordinate because isn't this a coordinate?
Yes, sir.
It is. Remember, the -3 represents what? What does the -3 represent?
X.
The X
And,
value.
yes.
And the Y represents the Y value,
2.
which is 2, right? Now this is how we represent a coordinate as a vector. So this is what we do. Is it because it's a position vector? Because if you look here, this is actually what? This is A, right? But what we do, we write it as OA. So OA.
So, sir, you couldn't say AO?
Because it's a position vector, and it says, if you look
From
at
the origin?
right, if you look at the definition, it says what? The position vector is movement from the
origin.
From the origin. All right. And you wouldn't want to start. Remember, a vector has 2 points. You can say AO. Nothing is actually wrong if you say AO, but in the initial stage, you wouldn't want to say that. You would want to say from O to A. But it is fair enough for you to ask. Yes, you can actually say AO. All right?
Okay.
Yeah. So OA is going to be -3. And then 2. Make sense? what the top number represents in this vector here as a vector. The number of units that goes where?
Repeat that, sir.
What does -3 represent?
X.
Yeah, okay, for the coordinate, it represents x. But as a matrix, as a vector, what does the -3 represent?
Number of units to the left.
Very good, yes. And what does 2 down here represent?
Number of units.
Going up. It will be going up, Andrew. Yes, you're reading the notes, man. Very good. All right. As Bennett says, you could actually have AO. Can someone tell me what you think AO would be? We have OA at the top. What do you think AO is? And if I say what is AO, what type of vector is AO? Starts with I. So vector OA and AO, they are called what? OA would be vectors what? Would be the inverse vector. Remember that? Types of vectors?
Inverse.
Right. So what would be the inverse of OA? What should go at the top here, sir?
A -2.
Well, you know, say that again? You're a bit low. You're a bit low.
A is equal to 2 over -3.
No. You know what you did is to flip the numbers. What you do is to change their sign. So the -3 becomes what? +3. And the +2 becomes what? -2. All right. So we would have done this last class, types of vectors. As a matter of fact, there's a video of this, not true? Types of vectors. All right. So let me encourage you to just read your notes and try to catch on here. Okay. So what I want you to do is I want you guys to write down O to B as a column vector. And then now I want you to write out what is BO. All right, that should take you more than 30 seconds. Go ahead. All right, quickly, what is OB? As a vector.
6 and 4.
Right, 6 and 4. And what is BO?
-6 and -4.
-4.
Awesome. Very good. Everybody following? All right. Then now, what I wanted to do is say, oh boy, I wish I had more space. Forgive me, forgive me. Suppose I have to find AB. Find the vector AB. That's the question. What would you do? How would you find the vector AB? How you go from A to B, class? A to where?
A to O.
Right, A to O. Very good. And then what? O
To
to
B.
O to B. So that's my question, you know. Determine the value of what? A to B. So to answer the question, you have to write out the vector equation or the position vector equation, as a student would have referred to it as. And the vector equation is A to O and O to B. By the following? All right. What is A to O? It's to the left of the screen. A to O is what?
-2.
3 and -2. Very good. Plus O to B. Hold on. Oh, yeah. I thought I made a mistake a while ago. All right. I thought I used OA a while ago, but it's actually AO. What is O to B, class? It's to the top right of your screen. O to B is
6, 4.
6 and 4. How do you work out the value?
Sir, how you get the 4?
You mean the 6 and the 4?
Yes.
See the value they put on the screen here, mom? They tell that B is 6, 4. See it?
Sir, if they had not given us the coordinates, 6 and 4 up there, so we would have to work it out.
Yes. Well, it's not a matter of work. If you wouldn't, I wouldn't call it workout. But what you would have done is just identify where the value is. So it's at the 4th position. So you write in 6 and 4. Okay.
Sir, I understand how you get the 6, but I don't understand how you get the 4. The 6 is right there. I was kicked out, sir, so I'm lost.
From which point?
The O to B.
All right. Do you understand what the value of B is? Do you see how they get 6 and 4?
B, I see 6 and 4 here, sir, but I know that the 6 is
All right.
6.
Hold on. Let's go to A. Do you understand how they get the A? -3 and 2.
No, sir.
Because
The -3 is right there, right? At the end of the point right there. So where do you get the 2 now? At the arrow there?
See there, mom? Right there.
Okay.
It's on the Y. Remember 2 represents the Y value, you know.
Right.
Yeah, man.
Okay.
All right. And the same way we get the A, same so we get the B. Do you still get the 4 now? The 4 is on the Y.
Oh, yes. Yes, sir. Understood.
Okay. You came to our Saturday classes, right?
Sir, of course, sir. I don't know just something a while ago.
We did 1 million graphs, you know. It's like plotting points, really. So if you look at B, 6,
Sir,
4.
the board just jumbled, so and I was kicked out.
Oh. All right. Okay, so All right, so basically what we do, we add these two values here to get the answer. So 3 plus 6, so we add 3 plus 6, we add negative 2 plus 4. And that will give us what?
9 and 2.
9 and 2. So that's the value of A. That's the value of AB. All right. So remember this piece here. This piece here came down from up top here. All right. So take off that. All right. Can I move on?
Yes, sir.
All right. Anybody else writing? All right. Okay, I'm gonna clear this. Wow, looks better, not true? Right. Okay, so another way of getting A to B is actually to measure it on the graph. All right. So basically, what we do is we just construct a what? A right angle triangle from A to B. All right. So if I want A to B, I don't have to do the vector equation thing nor the matrix business there. I can just take my graph and what? And measure it. All right. So all I need to know is how many units. Where am I going? I'm going from A to where? B. So it's 0, 1. I'm going right? How many units to the right am I going? Turns out to be 9. So it's plus 9 to the right. And after I go right, I go where? Up. So it's 2 units up. So you notice, I worked out the same thing a while ago using the vector equation mathematics. And then I just what? Basically just use the graph and determine my answer.
Sir, better I do it that way.
All right, good question. The problem is that sometimes the graph is not given to you, and that's when it becomes problematic. So you have to learn it both ways, yeah?
Yes, sir. So when the graph is given to us, we can use this
Right,
method.
right. Just like when we're doing coordinate geometry, you know, when you get a line segment and 2 points and it asks to find the gradient, we can either draw a triangle and find rise over run, find the gradient, or we can use the formula y2 minus y1 over x2 minus x1 to get the gradient. Anyone will work. All right. So that was what I was showing you. All right. So let's scroll on. I guess down below is just the working out that we did a while ago. So it's the same thing here. All right. All right. I want you guys to take off question number 1. Hold on. Let me stop. Just give me a second there. All right, you know what? Let us go to the graph. And then later we can go to the questions without the graph. All right, so please sketch. Oh boy. Take out that question and sketch that diagram for me. I can't, the questions are below here, so I will, in due time, I will show you the questions. So sketch it for me.
No worry, no worry. Big man up in there. I did do my work. And everybody get to it. Big man sitting in me what? Hard work. Hard work. God. Yeah, so I miss make you work. Making me see a problem. You found them in give me them today. I don't know. I have to make your phone the pan one heading.
Kristen, mute your mic, please.
My mic is mute.
Who is talking?
Daniel.
Okay.